numbers are they?
Multiples of 3.
Simpler than that.
Yeah, all odd numbers.
And what is 150?
Even. Okay.
Yes. And so sometimes it's simpler. It's a simple thing. I'll just give you the general method that will always work. How do you do this top one?
Um, 2 times 3 is 6 plus 1 7.
Yeah, 2 times. Well, that's the third term. What would be the first term?
3 and 5 the second.
Yes. So the first term is when n is 1. The second term is when n is 2. The third term is when n is 3, and so on. How would you do the one then the bottom?
Question. $20 minus 5 times 10.
Yeah, that's correct. And then you just work that out. It's just business after that. How would you do top one?
2 times 1 squared is 2.
It's not the first 3 terms, it's the third term.
Oh, okay. 2 times 3 squared is 9. Which just gives you, 3 squared is 9, so 18 in total, minus 4, 14.
Yes. So these are non-linear sequences, geometric, because they have squared. Okay, do you remember how you do these?
I think so. So there's a difference of 5 between each. Each number. So I think it's n plus 5. No.
It is 5n.
Just 5n?
And 5n is the 5 times table. So in general, they can all be written in the form dn plus c. So that's similar to mx plus c. Dn plus c, but it's for a sequence. It's for discrete numbers, like you won't have halfway in between. D is what you did there. It's the difference. Term 2 take away term 1. And C is term 1 take away D.
Okay. So is it 5n minus 3?
Yes. Term 1 take away D. So it's basically if there was a term before 2, that's the C. So it's like the y-intercept. It's a bit like that when x is 0. So it's like when n is 0. That's what it would be.
Okay.
But basically term 2 take away term 1 and term 1 take away D. So how about the last one?
Difference of 7 each time. So 7n minus 4.
That's it. 7n minus 4. So that's it in general. 7n minus 4. It's like 7x plus 4. That's the same type of thing. How would you do this one?
Difference of 6 each time. 6n plus 4. No, it's wrong. 6n. Yes, plus 4, sorry. 6n plus 4. So find the 10th term. 6 times 10 is 60 plus 4, 64.
Yes, and so quite strangely, it's for some students won't be able to do part B, so they put part A first because they can probably just keep adding 6 even if they don't know how to do it. But the best way to do it is to do question B first and use that to do question A.
Okay.
And that's just why that's like that. Yes, let's try this one.
4n minus 2
And part B?
is 86 a term in the sequence. Could I do 4n minus 2 equals 86?
Yep.
So plus 2 on both sides gives you 88.
Mm-hmm.
The 88 divided by 4 gives us 22.
Mm-hmm. So is it in the...
No,
Why not?
because 18 plus 6 isn't 22.
The answer is yes.
Oh yeah, sorry, 18 plus 4 is... Okay, sorry.
It's term 22. It's a 20-second term. So if you've got like first, second, third, fourth, fifth. If you go for long enough, 20-second term will be 86. What kind of number answer would you get if it was no? If it wasn't
An odd number?
nope. It would be a fraction or a decimal. Basically not a whole number. So see the way you've got like term 1 and term 2?
Yes.
4 isn't in the sequence because there's no term 1.5.
Okay.
So it can't be term a half or term 2/3 or something like that, 2 1/3. It has to be
I understand.
21st, 22nd. But the method you used was correct. Find what the nth term is, make it equal to that, and then see which term it would be. Let me think about this. Let's try top one.
Plus 6 each time, so 6n plus 5.
Mm-hmm.
Yeah. And then 6n plus 5 equals 121.
Mm-hmm.
Minus 5 on both sides, you get 6n equals 116. And then do 116 divided by 6. We get a fraction, so no, it won't be in the sequence.
You must explain your answer.
Because you can't have n being a fraction or a decimal.
Yeah, n, let's say, must be a whole number. Yep. Yep. N can't be not a whole number, I suppose. Great. Any questions about that?
No.
Okay. So that's the main thing with linear sequences. dn plus c. D is the term 2 take away term 1, or basically any term take away the previous one, and it's just usually easiest to use the first two. And C is the term 1 take away D, was basically term 0. Make that equal to the number and then solve it. Okay.
Okay.
Okay, what are these things about? Any idea how you do this?
Yeah, maybe. So,
Okay.
is 7 plus 3n, is that, if the first term is 10,
Yes. What will be second term?
13.
Yeah.
And the third.
And so on. Yeah.
Okay.
How about no? Let's not get silly. That's fine. So it's just a different notation. That's fine. Yeah, we did that one. That's fine. Okay. Fibonacci sequence. Do you know how to do these?
2 plus 3 is 5. 3 plus 5, 8.
Yep. 13 and so on.
Yeah.
Great. Great. Did it. I'm not doing silly stuff. Okay. Arithmetic sequence. You have a common difference. You're adding something, the same number each time.
Okay.
Geometric sequence. You're multiplying by the same number each time. So instead of plus 3, plus 3, plus 3, it's times 3, times 3, times 3.
Okay.
Okay, first 4 numbers in the first sequence.
1 over 1 is 1.
Yep.
1 over 2 is a half.
Yep, and so on. How about B?
2 is the first one. Then 4.
2, 4, third one?
8.
Yep, great, you've got the idea. So it's being multiplied by the same thing each time. What is this asking us to do? Probably find, I don't know, hang on. Write down the first 5 terms of these. Okay, let's do part A.
I've done the first 5 terms. So I have to multiply by root 2 each time?
Yep.
Based on the first term, root 2?
Yes.
Okay. So root 2, 2.
Yep.
2 root 2, 4.
Yep, great. Great.
Okay.
So those are kind of revision things. Okay, work out a formula for these. Do you know how you do this? You probably don't. No one does.
Isn't it the first? So there's a difference of 3 between the first one, 5 between the second, and so on. And then you have to find the difference between those.
Great. So that's 3, 5, 7.
7, 9.
Okay.
And then find the difference between those, which is 2 each time.
Uh-huh.
So 2n.
It will be, so these are geometric, meaning it's like quadratic.
Okay.
Remember the previous one, instead of mx plus c, it's dn plus c. For these, instead of it being a usual quadratic ax squared plus bx plus c, so all quadratics can take that form, that's a general form of a quadratic. These have an n instead, an squared plus bn plus c. What you just found there, let's see, how do we find a? A is equal to, I believe it is half of the second difference. Half times second difference. Yes. And so, what is half of this 2?
1.
And so a is 1. So it'll be 1x squared, or sorry, 1n squared.
Okay.
How do we find b and c?
Not sure at all.
To find c, that is going to be the same idea. Term 0, the term before the first term.
Okay, so in this case, is halving it.
So you said it was the first time it was like plus 3, plus 5, plus 7, plus 9.
Okay,
Working
so 1 this time.
Yeah. And so what is
So
C?
1.
Yes, it will be minus 9, minus 7, minus 5, minus 3, and so minus 1. So it's going to be 1. And how do we find B?
I don't know.
If you were to sub in, so in general, it is UN is equal to, so with the other one, it's UN is equal to DN plus C. With this one, it's UN is equal to AN squared plus BN plus C. So basically the first term, let's say U1, if you subbed 1 for N, what would you get?
1 squared, so 1.
1 times A?
1a.
Yep.
So 1, okay. 1b.
Yep.
And plus c.
Yes, and so basically the first term in any sequence, in any geometric sequence, is always equal to A plus B plus C. What is the first term?
1.
No. That's the 0th term.
Okay, so 3.
No. First term in this sequence? Term.
Oh, 2, okay.
Yeah. What's A?
1.
We're trying to find B. Do we know C?
1 as well.
Yes. What does that tell you what B is?
B has to be 0.
Yes. And so we have found A, B, and C. So what is the nth term for this sequence?
I'm not sure, I've never seen it done like this. So I'm quite confused.
How did you do it? So basically, so AN squared plus BN plus C. If A is 1, then it's 1n squared. If B is 0, then that's 0n's not there, and then C is 1. So it's n squared plus 1.
Okay.
Why did you use it? Do you know a different method that you prefer?
No, I don't remember. But
Okay.
I think I would have remembered if I would have seen the similarity between quadratics and this.
Okay. So we'll try another one. Let me think about this for a second. Let's try the last one.
So the difference between each is 5. Well, 5 is the first one. Then 7, 9.
Hang on. Let's try the second one instead.
Okay. 3.
Yeah.
5. And 7.
Oh,
yeah,
these ones, they're all just... Alright, we'll go back to the last one. So that was 5, 7, 9, 11. Go on.
So the difference between each one is 2. Then we had AN squared plus BN plus C.
Yeah.
So then A was half of the term, was half of the, okay, so is 1 in this case, isn't it?
Yes. Another way to say, like 2A is the second difference. And
Okay.
so 2A is 2, so A is 1.
C was was the first term, so in this case it would have to be minus 1.
What would you have to subtract?
1, I think.
So it's like minus 11, minus 9.
Oh, sorry, I was looking at number 2.
That's
Okay, so this one would have to be one, just 1.
Yep.
So then we have work out b, so an squared is just 1, so a plus b plus 1 or 1c, so it's just c, equals 2.
How do you get 2?
2 being the second difference, I think.
It is first term.
Okay. So 4 in this case.
Yep.
And so if a is 1, b is 2, and c is 1.
Yep. So b is 2, and so what's the nth term?
N squared plus 2n.
Sorry, n squared plus 2n. Yep.
Plus 1.
That's it. That's it. You've got it. And these things will never change. So it will always. So 2a is always equal to the second difference. So 2a equals second difference. C is equal to 0th term. And b is equal to, well, I'll just write it as a plus b plus c equals first term. Yeah. It will always work, however weird it gets. Let's see. Work out the next term. That's easy enough. This is a bunch of stuff. The nth term. Yes, let's try this one.
The second one or the first one?
There's only one question. That's up there is just like just
Okay.
a reminder.
So the difference between each is 15 for the first one, 25 for the second one, 35 for the third one. So that's a difference of 10 each time.
Mm-hmm.
So an squared plus bn plus c. So I think a was 2a is the second difference. So a is the 5.
Yeah.
C has to be first term, so 5. No, wait, it has to be 3.
Yes.
Yes. And so we can write out as a times 5 squared.
No. You found A, you found C, now find B.
Do we have to substitute the...
Do you remember how you found B? A plus B plus C equals U1, first term.
Sorry, 2 seconds.
All right.
Sorry. So the first term is 8.
It's not. Yeah. Okay.
So A is 5A. No, yeah. So A is 5, and C is 3. So 8. So B is 0.
Yep. And so, what is the nth term?
Have to be n squared plus 3.
What squared? Sorry.
N squared.
Something's missing.
Five n squared.
Yes, that's it.
Okay.
5n squared plus 0n plus 3. Yeah, so just like with a quadratic, ax squared plus bx plus c, an squared plus bn plus c, it's always going to be that. And what we did the very first time was we just kind of proved it very quickly. So we just proved that the second difference was equal to 2a. We proved that c is the 0th term, and we proved by subbing in 1 that a plus b plus c is the first term. But once you know those things, you can just use them again and again, so you don't need to prove it. Just half the second difference, find the 0 term and sub them and the first term into a plus b plus c equals the first term.
Okay.
And you can get it that way. These are going to be similar. I just want to see, do I have exam question or something like it? Okay, let's practice the last one here, D.
So the first is 8, difference between 3 and 11, then 14, then 20. And the difference between these ones is 6.
Second difference is 6.
So A has to be 3.
Yep.
C has to be 2. And B would have to be, so A plus B plus C equals the first term, which is 8.
And let me see this. Hang on. 2. How did you guess C is 2?
Because 8 minus 6 is 2.
So that means we are subtracting 2.
To get the
so it's
0?
So it's it was minus, hang on a second, let me make sure. I think I just threw in a 26. The second difference, 1, 2, 3, 4, that was 20. So 71 take away 45. 45. It's 26, yep. So it is minus 26, minus 20, minus 14, minus 8, and for the last one it will be minus 2. So you subtract 2 from that.
Oh, okay. I understand what I was wrong. Okay. So, yeah, minus...
So let's see.
Should be 3 minus 6, yes?
No, 3 minus 2.
I don't understand why it's minus 2.
So if we were to, so it was 8. So going this way, it would be plus 8, plus 14, plus 20, plus 26.
Yep.
And you said that that one would be 2. That's the first difference. So working the other way, it would be minus 26, minus 20, minus 14, minus 8, minus 2. So to get the term before 3, you would take away 2.
Okay. Okay. So C equals minus 2 in this case?
No. C is 3 minus 2.
Okay. I understand a bit. Okay. 1. So
I'm gonna have to find some formula for C. It's a tricky one. Okay. What's next?
And then A plus B plus C equals first term, which is 3.
Mm-hmm.
So A has to be 3. B has to be minus 1.
Yep. So B equals minus 1. So what's the answer?
3n squared minus 1 plus 1.
Minus 1 what?
N.
Yeah, minus 1n. That's it. So it's just like a quadratic. It would be like 3x squared minus x plus 1. Okay. Any questions about that?
No.
That's easy, tricky one. That's alright. So this is what exam style question looks like right down the first 4 terms. State the term-to-term rules, such as what's happening each time, and use algebra to show that the product of any 2 terms in the sequence is also a term in the sequence. Is that what they look like? The nth term of a sequence. So before we do that, we've done this, this is just proving it. Yeah. Yes, so what I'm gonna do, okay.
And so we were told to, underneath it, put U1, U2, U3, U4, U5 for each term.
Mm-hmm.
And then that the formula was UN plus 1 equals 2UN.
Okay.
That's it. Is that what we were doing, or?
Yes, mostly. This is they have a special name for it. Well, anyway, okay. So what you had to show that this was a formula for the sequence.
Yes.
Let me just check actually what it's called. So that was that one for the 6th term, and this one's okay. And then let's get this one. That's part A, and then show that the 5th term is that's not bad. I just want to get these while they're there. Just throw it in. Don't have to be pretty. And this one. Yeah. So the name of those ones, edit search, content. And then they don't have a name at GCSE. I believe they call them recurrence relations. Yeah, but it is a geometric sequence. So you have to show that the next term in the sequence is 2 times the previous term.
Yes. So, for example, if we're trying to find U2, which is 6 in this case, I think you have to prove that your formula works. So un plus 1. I'm not even sure. This was 3 days ago and I can't even remember. So you and replaced the n with a 1.
Yeah.
So un plus 1 becomes u1 plus 1.
Yeah.
And then equals 2un 2 times u1, which is 2 times 3. So 6. u1.
So 6. Yep.
Okay. Yeah.
Yeah. Okay. So it's kind of similar to. It was just a question that I skipped over, just because it's like I don't want to do like these one weird questions type of thing. But so this is similar. Okay. So how do we do this?
The time of sequence is un equals 10n. Okay. So u5 would have to equal 10 to the power of 5.
Yeah. So that's gonna be a 1 with 5 zeros.
100,000. Yep. And then so 10 to the power of 8 is 1 with 8 zeros. So
I'm just gonna leave it as 10 to the 8.
yeah. And so u13 would be 10 with 13 zeros. And I'm not too sure, maybe 10 plus 5, 10 to the power of 5 plus 10 to the power of 8 gives you 10 to the power of 13.
Yeah. 10 to the 5 times 10 to the 8 is equal to, I think to prove it you'd have to show 10 to the power of 5 plus 8. So you have to show that.
Okay.
10 to the 13, which is u13. Therefore, because it's a proof that, just write that, or show that. Therefore, I have to say product. Yeah. Therefore, the product of u5 and u8 is u13. So, yeah. So then, okay, exam style question. Part C uses that. So let's do this.
Okay, use algebra to show that the product of any two terms. Okay. Do we have a term or?
You're given a rule. You have to state the first 4 terms. So you have to make the sequence yourself.
Okay, so the first one would be 2.
Mm-hmm.
Then 4. Then 8. And then 16.
Mm-hmm.
And then to show, you could probably do 2 times 4 equals 8, which is u3.
So these will show the product of any 2 terms in the sequence is also a term in the sequence. Say it again, what would you do, sorry?
So 2 times 4 equals 8, which is u3.
8. And so that's the same as u1 times u2 is equal to u3.
Yeah.
But how do we prove it? We want it in general. So instead of saying what you showed here was what you did here was 2 to the 1 times 2 to the 2 is equal to 2 to the 3.
Yes.
We want it in general. So how would you show it in general?
Two n times 2n plus 1 equals 2n plus 2.
Brilliant. 2 to the n times 2 to the n plus 1 will be equal to, so don't skip this step, 2 to the power of, what would you show here?
N plus 2.
These two added together, n plus 1. Simplify.
Yes, okay. So 2n plus 1.
Yeah, So
Got that one wrong.
2n plus 1. So yeah, don't skip that step. So not just to make sure you don't make any little mistakes, but also because it's a show that question, so you have to actually show it. They give you the answer kind of, so you can't just say the answer. Great. So you're using n instead of a number to prove it. Any questions about that?
No.
Okay, and if we just go... Oh, so here's another one that's similar. Oh, that's the answer, sorry. Yeah. There were very few of those. This was proof. Let's go back to your one. So yours was this, okay. Let me just go back to this. Okay, so this was an exam question. How do we do this one?
Yeah. Minus 2 times 12.
Why is that?
U2 times U4 gives you U6, I think. Maybe, I'm not too sure.
Might. So this is more similar to the ones you and I were doing.
Yeah. The answer of sequences. So could it be times 5 each time? No, plus
2,
5. Plus 5 each time. So.
That would be for an arithmetic sequence. This has squared, so it's geometric. It's not plus something each time.
Right, so the difference of both of these is 10. Well, actually, no, so 12 divided by minus 2.
So you kind of had the right idea. It's not plus something each time, it's times something each time.
Is it times minus 3?
Hang on, how does this work? How can that be negative and this be positive?
So what times minus 3?
So minus 2. No, something's wrong here. Hang on. Which one am I looking at? This was 6. Yeah, find the 6th term. The nth term of the sequence is given by that. Second term, fourth term, find the 6th term. Add that one. Next game. So they did this a different way. So this is the second term. So what is n for this term?
N squared plus n?
Like, what is n for the second term?
Does n squared plus bn have to add up to minus 2? No, it doesn't. Okay.
So how would you, if you knew the nth term, how would you find the 6th term?
Implement it into the...
So let's say you had like 5n plus 3. How would you get the 6th term?
5 times 6?
Yeah, so basically you sub 6 for n. So with this one, the second term is minus 2. And so what do you sub for n?
Minus 2.
Just 2. The second term. Just the way you did with the 6. And so what do you get for it?
4a
Yeah,
plus 2b.
yeah. Do the same for the 12.
So a times 12
Uh,
squared.
what is n for this one?
Minus 12.
Oh, for the first term n is 1. Second term n is 2. It's the same as you did with the 6.
Okay. 4.
Yes.
So this a times 4 squared. So
Yeah.
plus b times 4. So that gives us 16a plus 4b.
B. Yes. So what we see is 16a plus 4b gives us 12, and 4a plus 2b gives us minus 2.
So I'm trying to work out. What am I trying to work out now?
We'll have to find a and b.
Double the bottom one, I'd say.
Yeah.
And then do the top one minus the bottom one.
Yes. Go on, go for it.
That gives us 12. 8a equals 16.
Yeah.
And so a equals 8a equals 16. And divided by a on both sides, 2.
Here's 2.
Yes, that b has to be. So put it back into the equation. So 4 times 2 is 8. 8 plus 2 times something equals minus 2. Minus 5.
Yeah. B equals minus 5. And so, nth term?
So do I put 2?
Mm-hmm.
So 2n squared plus, so minus 5, sorry. 5n.
And find the 6th term.
So 2 times 6 squared, 6 squared 36, 72. 72 minus 30 is 42.
It's 42. So a very, very tricky one with that gap using simultaneous equations. There you go. So that one, sub 2 for n, make it equal to the second term. Fourth term, sub 4 for n, make it equal to the fourth term. Solve them, and then use that one. So that's what an exam question looks like. And this one was similar. What was this one? A geometric sequence. See, I don't want to do these one weird thing. Given that are the first three terms of s, find the value of x. For this one, the other way it's times the same thing each time.
Okay.
So basically, if in an arithmetic sequence, Term 3 take away term 2 is the same as term 2 take away term 1, because it's the same thing each time. For
Does that rule apply as well for term 3 divided by term 2?
Correct. For geometric, it's divided by. Term 3 divided by term 2 is equal to term 2 divided by term 1.
Okay.
And so you can use that to make an equation. Square root of x plus 1 over 1 will be equal to 1 over square root of x minus 1. And then you just solve.
Will you always be told if it's a geometric or arithmetic equation?
For this, you would have to be told it's geometric, because you couldn't know otherwise. It could just be adding something. Yes, so in general, so it's a lot like those like quadratics, but we saw they're sometimes called quadratic sequences. You saw there second difference is 2a, so you halve the second difference to get a. Term 0 is c, and then a plus b plus c is the first term, and you use that to solve them. Linear sequences, arithmetic sequences, it's dn plus c. D is the difference and c is term 0. To see if something is in the sequence, you make the nth term equal to that number and solve it. If n is a whole number, it's in the sequence. If n isn't a whole number, it's not in the sequence. And those are the main questions for it. How was that for you, Hugo?
I didn't understand all of that at first, but yeah, it was alright.
So any topic in particular you want to do next time?
No, I'm not sure.
Alright, well, I've got some new stuff anyway. Any questions for me in general?
No.
Alright, well done, Hugo. You did great. When's your mock?
Tomorrow.
Alright, well, good luck on it, and yeah, have a good week. Talk to you next time.
Thank you very much. See you. Bye.
Good night.